We will now discuss the solution of a problem from the section Statistics and Probability. This problem is on probability related to 3-digit numbers. This problem has appeared in the Joint Entrance Examination Main held on 28th June 2022 in the session 1. The given question is the probability that in a randomly selected 3-digit number with at least 2 odd digits is. We have 4 options. Option A 19 by 36, option B 15 by 36, option C 13 by 36, option D 23 by 36. Now we have to compute the probability that in a randomly selected 3-digit number that has at least 2 odd digits We now discuss the solution of the problem in detail. Let's now take capital D as the set of digits. Capital D is the set consisting of the digits 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. And D star denotes non-zero digits, namely 1, 2, 3 up to 10, leaving the 0. Let O stands for the set of odd digits, namely 1, 3, 5, 7, 9. E stands for the set of even digits, namely 0, 2, 4, 6, 8. And E star stands for non-zero even numbers, even digits, that is 2, 4, 6, 8. Now, when we talk about the probability, first we talk about the sample space. The sample space is the set of all 3-digit numbers without any constraints. That means no conditions are given. Conditions like they are all distinct or repetition is allowed, something like that. So let S be the set of 3-digit numbers with no constraints. That is, S is the set of all 3-digit numbers. A, B, C. These are A, B, C are digits, 3-digit number, where A belongs to D star. Why? Because you cannot have a 0 in the 100th place, that is in the place of A, to get a 3-digit number. Therefore, if it is a 3-digit number, it should start with, that is the 100th digit must be non-zero. So A belongs to D star. BC can be any digit. BC belongs to D. Now we ask the question, how many such 3-digit numbers are there? That means, what is the order of S? N of S. N of S is equal to number of elements in S is equal to, by the product rule of counting, it will be the number of choices for A multiplied by the number of choices for B multiplied by the number of choices for C. The number of choices for A is N of E star, N of D star, because A belongs to D star. So, N of D star into number of choices for B belongs to D, N of D into N of D. N of D star is 9, N of D is 10, n of d is 10. It will be 9 into 10 into 10, that is 900. Agreed. Therefore, n of s is 900. Now, let A be the set of 3-digit numbers with at least 2 odd digits. Because you have to randomly select a number, and that should turn out to be a 3-digit number with at least two odd numbers. That is why we are considering A is the set of 3-digit numbers with at least 2 odd digits. We continue in the next slide. Yes. Now let A be the set of 3-digit numbers with at least 2 odd digits. Then the required probability is n of A by n of S. Agreed. The required probability is n of A by n of S. Now, what is the n of A? That we will see in the next slide. So we have A is the set of 3-digit numbers with at least 2 odd digits. Then A will contain 3-digit numbers with all the 3 digits as odd, and the other variety is the set of 3-digit numbers with exactly 2 odd digits. So that means A is the union of 2 sets B union C, where B is the set of 3-digit numbers with all the 3 digits as odd, and C is the set of 3-digit numbers with exactly 2 odd digits, exactly 2, and there in B all the 3 are odd. Agreed. Now, note that no element is common between B and C, that is B and C are disjoint. Then in that case, n of A, number of elements in A, is equal to n of B plus n of C. Why? There should be minus n of B intersection C should also be there, but B intersection C is empty, and that is why that's not there. Right. So we will now go to B and count the number of elements present in B. Now B is the set of all 3-digit number A, B, C, where all the 3 digits are odd. A, B, C are odd. So n of B will be the number of choices for A multiplied by number of choices for B multiplied by number of choices for C by the product rule of counting. So it will be n of O, because A, B, C are coming from O, the set of odd digits. So n of O multiplied by n of O multiplied by n of O. That is 5 into 5 into 5, that is 125. Agreed. So now C is the set of 3-digit numbers with exactly 2 odd digits. That means the third digit is even. So C is the set of 3-digit numbers with exactly 2 odd digits. Then it is the set of 3-digit numbers A, B, C with 2 of these A, B, C belong to O. That means 2 of them are odd. Then this C is partitioned into C1 union C2 union C3, where C1 is the set of 3-digit numbers A, B, C, where A is even. A belongs to E star because A cannot be 0. Therefore, A belongs to E star. A is even. The remaining B, C are odd. Agreed. C2 is a set of all A, B, C, where A and C are odd. The middle one, B, is even. Now it can accept it. B can be even 0 also. That is why B belongs to E. C3, the set of 3-digit numbers A, B, C. A, B, the first two are odd. The third one, C, is even. C can also be 0. That is why C belongs to E. And note that they are pairwise disjoint. That means C1 intersection C2 is empty, C2 intersection C3 is empty, and C1 intersection C3 is empty. So, if that is the case, what is the N of C? C is C1 union C2 union C3. They are pairwise disjoint. Therefore, N of C will be equal to N of C1 plus N of C2 plus N of C3. The other terms, they are 0. Agreed. Now, let's get into C1 and count how many elements are there. So, now N of C1 will be, the choices for A is N of E star. The choices for B and C is N of O. So, N of C1 into N of is equal to N of E star into N of O into N of O. That is 4 into 5 into 5, that is 100. N of C2. A is odd. So, the choices, number of choices will be N of O. B belongs to E. Number of choices will be N of E. For C belongs to O. Therefore, number of choices N of O. So, this will be 5 into 5 into 5, 125. In a similar fashion, N of C3 is also 5 into 5 into 5, 125. And N of C is the sum of all these three numbers. So, N of C is equal to 100 plus 125 plus 125, that is 350. Agreed. Agreed. Now, thus, N of A, see, look here from the previous slide, N of A is equal to N of B plus N of C, but N of B is 125. So, 125 plus N of C is 350. So, the total is 475. Therefore, the required probability is N of A by N of S, that is equal to 475 by 900, and after cancellation it is 19 by 36. So, let's look at our options. Our answer 19 by 36, that is the required probability, appears against option A. Therefore, the answer to this question is option A. So, that is the detailed discussion of the solution of the problem, which is on the probability of probability related to 3-digit numbers from the section Statistics and Probability. And I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you.